Cool. Okay, so yeah, as has been mentioned, my name is Kai. I'm a developer advocate slash developer here at Civo, and thanks to Cyan for the general intro to service meshes. What I'm going to do is use that as a jumping off point to talk about the service mesh interface and what it is. And unlike Cyan's handwritten slides, mine are going to be boring old presentation slides, but hope that's okay. So what we'll cover today is basically just some definitions, the scope of SMI, what it's actually intended for, developing with the SMI, the service mesh interface specification in mind, and how you can get involved in sort of things around both the SMI and the wider service mesh cloud native landscape. So some definitions first. The SMI was originally started by a sort of consortium between Microsoft, HashiCorp, Buoyant, Solo.io, and a couple of others in May 19. It is a CNCF sandbox project since May 2020. And CNCF is a project of the Linux Foundation, and basically what it does is it aims to uniformly advance containerized cloud native technologies without being sort of preferential to any particular company. And they maintain a landscape of projects and technologies, and their relative maturity is reflected in what they're called. And so with the SMI being a sandbox project, it means it's an early stage project. So obviously there are already developed and established service mesh technologies out there. And this sort of SMI is almost like a distillation of all of those things. It's come later, which is why it's effectively slightly in an earlier state. So the spec is just that. It's a set of definitions and standard APIs, like Cyan mentioned in his presentation earlier, that cover the sort of commonly accepted and commonly understood capabilities of service meshes. And we'll talk about more of those capabilities on the next slide. But the general, it's a very general project. It's not meant to be bound to any particular provider or implementation. So it's a set of sort of criteria and custom resource definitions for Kubernetes, but it's not a service mesh product, and it doesn't aim to be. It only sort of, it's meant to be a living specification which develops and evolves with the changes in cloud native and service mesh technology. So SMI is managed by the contributing team. It's effectively an open source CNCF product. And like I said, just as as service meshes are developing, this develops as well. So it aims to define the core concepts and capabilities of a service mesh. And currently we're at version 0.60. And the core concepts and capabilities that are defined in SMI are traffic policy, traffic telemetry, which is getting data out of your traffic information, and traffic management. These are not the fixed categories, like as the specification documentation says. We expect that over time, as more functionality becomes commonly accepted as part of what it means to be a service mesh, those definitions will migrate into the SMI specification. So what this kind of thing isn't new. For example, CSI, the container storage interface, there's a couple of other sort of cloud native open projects which aim to define a standard, and how you implement that is almost up to you. So the SMI doesn't want to prescribe to you how to manage traffic in a Kubernetes cluster. They just tell you that these are some of the ways that you can specify these sort of policies.
Just to jump in quickly, Kai.
Yep.
As you mentioned, container storage interface and CSI. If you sign up for our next webinar next month, I'll be giving a talk on how to write CSI drivers.
I was about to come to it at the end of this slide, actually.
Fantastic. I'm jumping to plug it as I hadn't had the tip.
Yeah, no, absolutely. So without something like these sort of universal or standardized APIs specifications, developers would have to learn the spec of each implementation separately. So let's say that traffic management and traffic splitting in a product like Istio would be designed completely separately and completely differently to traffic mesh. And that would mean that anybody wanting to work between the two would have to learn the new specification entirely. And what this aims to do is to sort of lay a groundwork and then leave the door open for innovation and new technology. So, if you want to work with SMI, most people, if you're sort of doing SMI spec stuff directly, you're probably doing it through an already installed service mesh rather than calling any kind of APIs directly. And this is a sort of screenshot that I took from the Linkerd blog, which uses an SMI spec API to apply traffic management to a cluster and have it serve traffic based on that weighting. And this is the example here was sort of injecting error rates to detect service degradation. So as an SMI user, I write the instructions and let the interface handle it. And so that sort of abstraction takes away having to know exactly how the technology underneath it does the actual work. So you're sort of calling a sort of the app most likely your service mesh application has an operator that then calls the translates to the SMI sort of specification. Then again, you've also got the traffic mesh implementation, which is in contrast to, for example, how Linkerd does it. So Linkerd has almost like a shim, which sits and translates between Linkerd zone tech and the SMI spec using sidecar containers. The traffic mesh is a service mesh built from the ground up to consume just the SMI spec APIs. And Kevin Crowley, one of the authors, said that the SMI APIs provided a clear consensus on features that had been widely adopted across the landscape, thus ensuring the engineers didn't waste time addressing limited use cases. So if they were building for a service mesh from the ground up, they knew that these were the things that that service mesh would have to cover to serve user use cases. Obviously, it wouldn't necessarily cover every single use case, but it would be sort of a starting point. And that's kind of what SMI, intends to do. But because they're doing it natively, sort of aiming to have SMI compatibility, they don't actually need sidecars to translate between the API spec and any kind of other technology because they're building directly to that native spec. So, I mean, this is a very quick overview of a kind of overarching kind of project. It seems a little bit like the community around SMI is maybe slowing down a little bit. And it could be because service meshes are kind of becoming very, very mature in many ways. And so I just wanted to highlight that if you are interested in SMI more widely and sort of these kinds of standards and standard setting and how you can make sure that your whatever project you're working on sort of complies, there's the SMI channel on the CNCF Slack community, which you should absolutely join. They also do community meetings. They haven't had one this month. They're meant to be weekly, but I think they're due one end of this month. Plus, then, and this is something that came up when I was talking to Jason yesterday, and Jason's coming up next, is if you're interested in SMI and you want a product to make sure that it speaks SMI, speak to the product liaison people for that product. So, talk to the people who work on service meshes, whether it's, Jason and Linkerd, or talk, find somebody from HashiCorp if you're interested in how console does, sort of interfaces with SMI and ensuring that it continues to do so. That's a kind of surefire way to make sure that these projects are aware that there is demand for this kind of standardized overarching set of standards, because otherwise there's I guess a kind of danger, maybe not a danger, but like I said at the very start, it's intended to be a living, breathing kind of standard. So without, like, it would be a real shame if the SMI sort of stayed stagnant and all of these service meshes went their own different ways, because that would then mean that as developers, you would have to learn more and more new technologies rather than knowing that there is a certain applied standard. Um, so yeah, that's I'm happy to talk more about this in Q&A, but this was just a quick sort of 10-minute run around of the SMI spec. So hope you enjoyed that. Thanks.